completing the square. Here we go. So in this one I'm going to show you how to do the two different cases of completing the square, and then we're also going to look at a situation where completing the square probably isn't the best method of solving a quadratic equation. So you should remember that if you're given a question and you're given a choice of ways to solve it, you should always try to solve it by factoring first. So that's by doing the sum and the product part, which we all seem to know pretty well. If that doesn't work, completing the square is what you should look at next. So let's have a look at one here. Okay, so imagine we have x squared minus 10x plus 4 equals 0. Alright, so the first thing we need to do is to get that plus 4 to the other side. So we're going to write down x squared minus 10x equals minus 4. And we know then that we have to put something in here to complete the square, and it's going to have to add on to the other side as well. So what we can do, we know that to get that number, we have to divide this here by 2 and square it. Alright, so what you're going to get, if you half minus 10, you're going to get minus 5, and square it, you get 25. So you get x squared minus 10x plus 25 equals... Now because you've added 25 to the left hand side of that equation, you must add it to the right as well to maintain balance. Anything you do to one side you must do to the other, or the balance of the equation will shift. So you're going to get minus 4 plus 25. Okay, so now what I'm going to do, well, x squared minus 10x plus 25 is x plus something squared, or x minus something squared. Okay, so it's x, and we half the minus 10, we get minus 5, so that's x minus 5 squared. So what that means is, if you, x minus 5, if you multiply that by itself and expand it, you're going to get x squared minus 10x plus 25, and we should be familiar with these patterns at this stage. And that's equal to minus 4 plus 25 is 21. Okay, so let's continue. Now we need to solve that. So the operations that we need to reverse the minus 5, which will be reversed with a plus 5, and we need to reverse the squaring as well, which is reversed with a square root. But we have to do the squaring first, because the minus 5 is in parentheses, so it's the reverse of PEMDAS. Okay, what's in the parentheses is kind of protected. So we do the square root here, and we see that the square root and the squaring symbol cancel each other. But we also have to do the square root of the other side. So what are we going to get? That's all gone now. We're left with, I'm just going to erase that, sorry. We're left with x minus 5 is equal to the square root of 21. Put that in your calculator. I think it's going to be somewhere in the region of, let me see, 4.5 something. Okay, I'm going to say 4.5. And remember, it's plus or minus 4.5, because the square root, any number has two square roots. Okay, so let's finish it. So what we have then, x minus 5 equals 4.5, or minus 4.5. So to solve it then, we're going to do plus 5 everywhere, like that. And we're going to get x equals 9.5 or 0.5. So there's my two answers. Alright, so you just do it by solving the equation, then by adding the 5 to each of the solutions, or each of the possible solutions, you get your answers. So there's the answers to that. You can check it by substituting it into the original equation to see if it works. But that's the process. It's pretty straightforward, I think. I think we should be able to handle that. Right, let's look at the second case that we were talking about. So I'm going to show you something here that we worked out. Well, we were looking at a way of doing it in class when we were doing our tutoring before, but Ornella actually suggested this idea, and it works, and it makes more sense to me to do it like this, because it just cuts out one of the tricky parts of solving the problem. So let's have a look at this. Say for example we have 6 x squared plus 48x equals 34. Right, so we're going to start with that. So what I was doing, we were taking the 6 out and putting parentheses, say, with x squared plus 8x. Then we were completing the square in the parentheses and working from there. But Ornella, being the mathematician that she is, decided, or suggested, that what if we just divide everything by 6? Could we not just do that and solve it from there, the same way as the normal ones? To which I said, yes, indeed you can. So, we divide across by 6. But remember, if I divide one side, I must divide the other. Okay? So I'm dividing that 6 out. I'm not going to write it in beside in parentheses like I did before. I'm actually taking it out of the whole thing. So what I'm going to be left with is x squared plus 8x equals 34 over 6. You can check that in your calculator. It's going to be 5 and 4/6, so it's going to be 5.6, I would say. Alright? Now, let's complete the square. What would have to go on the end here to complete the square? Well, you halve the plus 8, you get plus 4, and you square it, you get 16. That means we must add 16 over this side as well. Okay, so we have x squared plus 8x plus 16, which is x plus 4 squared, and that's equal to 21.6. And now look, so it's just the same as what we did before. By dividing out the 6, I divided both sides of the equation by 6 and I got a new equation, and then I just completed the square with that. And that works. So if we have a look, we're exactly where we were with the last one. It's exactly the same. We go about first by taking the root of each side. What are we going to be left with? X plus 4 is equal to the square root of 21.6. If you check that in your calculators, I would say it's about 4.6. Check it in your calculators to see if I'm right. And we have our plus or minus. So we get x plus 4 equals 4.6 or minus 4.6. And then we subtract 4 from each side. That's my daughter screaming in the background there. Better go and see what's wrong. So x equals 0.6 or minus 8.6. And there's your solutions. Finally, let's have a look at an example of when it's not a good idea to use completing the square. Say, for example, we have 7x squared minus 17x equals 38. Alright, so imagine, so you've already tried to solve this by factoring. You've tried to sum on the product and it's not going to work. Or you've tried to sum on the product and you just can't figure it out. For example, in this case, you would have 7x squared minus 17x minus 38, because the factor, you need everything on the same side. You do 7 times minus 38 is minus 256, so that would be your product, and minus 17 would be your sum. That's going to be very difficult to find. So we're imagining the sum and product won't work. So we're going to do by completing the square. So by Ornella's method, we divide everything by 7, okay, the whole way across. And we're going to get x squared. So minus 17 divided by 7 is going to be 2 3/7. 2 3/7, you're talking 2.4x. And that's equal to 5 3/7, which is going to be 5.4. Okay, now if you look at this, when you want to find the term that you have to add on here and here, you have to divide minus 2.4 by 2 and square it, and you're getting really deep into decimals and kind of messy things like that, and that's not what we want. We want to try and keep this, if anything, we want this number in the middle to be a 0.5 or a whole number. If it's not any of those, it's going to get a little bit too messy and we need to start looking at using the quadratic formula. So that's your next step, would be the quadratic formula. When you see this, okay, and your term that you have to add on is going to be kind of a messy one, that's a sign it won't work in quadratic formula. Okay, so there's the examples of completing the square. So keep on top of this. Please use this video as a reference so that we don't have to keep repeating it in when we do our tutoring.